कॉफी दे ही दे।
Ma'am, please start. And ma'am, please unmute. Okay, thank you, ma'am.
Okay, sir.
Please start, ma'am.
Yes, sir. So good afternoon, everyone. Good afternoon, everyone. So let's start the another session of paper. Okay, sir. Sir, my mic is already unmute, sir.
No, ma'am, actually, your voice is breaking.
Okay, sir. Good afternoon, everyone. I hope my voice is clear and audible.
Yes,
Let's start with the another session of paper 5 of CMA Foundation. In the last class, we have discussed two topics of mathematics. We have done ratios, proportion, and time value of money, in which we discussed simple interest and compound interest. And sir, there is some problem, sir. Yes, good afternoon, sir. It's clear, audible?
Yes, ma'am.
Just a second, sir. So good afternoon, everyone. Should I start, sir?
Yes, yes, ma'am.
Okay.
Now it is okay.
Actually, the voice is echoing, sir. Whatever I am speaking, the voice is returning back again with a fraction of seconds.
But we are, your voice is clear, audible for me, ma'am.
The thing is whatever I have told now, it's repeating, sir.
Are you using any microphone or anything?
No, sir, I'm not using any mic, nothing. I'm just using the speakers of laptop, sir.
Okay, ma'am. So then let me talk to our IT team. I'll come back to you, ma'am.
Sure, sir.
Hmm.
Sir,
Yes, ma'am. Please.
sir, whatever the conversation we are going on, it's repeating the entire conversation, sir.
Can you exit from this meeting and again? Can you enter?
Yeah, sir, please.
Can you please exit from
Sure, I'm leaving, sir.
meeting? Can you leave? Please leave. Hello. The meeting. Hello, ma'am. Am I audible?
Yes, sir. Yes, sir.
Is it echoing now? Is it echoing now, ma'am?
Right now it's not echoing, sir.
Okay. Please carry on. Please carry on, ma'am. Please start the class.
Yeah, sure, sir. So good afternoon, everyone. Let's start another session of paper 3, that is business mathematics and statistics. In the last session, we have discussed two topics of mathematics. One is indices, ratio and proportion, and second topic is time value of money, in which we have discussed simple interest and compound interest. Now let's start the next topic of mathematics, and that is basically series. Sequence and series, in which we will be discussing two series. One is arithmetic progression and another is geometric progression. So first is arithmetic progression. Now what is AP? AP is basically a series in which there are sequence of items which are increased or decreased. Sequence of items which are increased or decreased by same common difference. So that line is very important. Items are increased or decreased by same common difference. Now what it means, I'll explain you with an example. Suppose you have T1, T2, T3 and Tn. These are the sequence of terms which are in AP, that is arithmetic progression. So I've told you that items are increased or decreased by same common difference. That means the difference between second term and first term, the difference between third term and second term, the difference between fourth term and third term, all these are equal to D, and D is basically common difference. So that is the meaning items are increased or decreased by common difference. Like for example, my series is 2, 5, 8, 11, 14. Now the difference of the term is 3. So items are increased by common difference 3. Now another value, if I say 36, 34, 32, 30. Now here the items are in AP which are decreased with the common difference 2. So this is called AP. So how to find out terms of AP? Suppose we'll say the first term of the series is A. And I have already explained you the difference between second term and first term is D, that is common difference. So if first term is A, that means second term is A plus D. First term plus common difference. Now the difference between third term and second term is D. So third term is basically second term plus C. So what is our second term? That is A plus C that we have already computed. So that means third term is A plus 2D. So if I want to find out the nth term of AP, then what is the formula for nth term of AP? That is A plus n minus 1 into D. This is the formula of nth term of an AP. So whenever you have to find out any terms of arithmetic progression, that means you need just two items, A first term, B common difference, and N the term whose value you want to find out. So by putting the values in this formula, you can easily find out the value of nth term. For example, now this is the series 26, 29, 32, 35, 38, 41. So if you just have a look at the series, the difference between the terms are 3. So they have the same common difference. So that means this series is arithmetic progression. Now what is A? A is the first term, that is called 26. What is D? That is the common difference, 29 minus 26, 3. Now I'll say find out the 15th term of AP. So how I can find out? A plus n minus 1 D. So now A is out nth term of arithmetic progression. So now another example, we have first term that is equal to minus 13, common difference is 6, and I want to find out first 5 terms. That means first term is minus 13. Second term I can find out minus 13 plus 6, that is equal to minus 7. Next term minus 7 plus 6, that is equal to minus 1. Another term minus 1 plus 6, that is equal to 5. And the fifth term is 5 plus 7 is equal 5 plus 6 equals to 11. So this way you can find out the terms. So I have already explained you the formula for finding the nth term of series, that is Tn is equal to A plus n minus 1 into D. So next question says, suppose you have been given the series. A given series is A plus 14, A plus 12, A plus 10, A plus 8, A plus 6. Now identify the type of the series. So to find out the type of the series, first you have to check it out, the difference between second term and first term, and third term and second term is same or not. So if I say second term is A plus 12, first term is minus A minus 14. So this is equal to minus 2. Similarly, third term is A plus 10 and second term is minus A minus 12. So again, this is minus 2. So common difference is same. So this is your arithmetic progression. Calculate the value of A and D. So now I have to find out the value of A and D. So how I can find out? The first term is a plus 14 and common difference is minus 2. So this is how you can find out the nth term of an AP. Now next thing is, suppose you have been given AP and you have to find out sum of n terms of AP. So what's the formula of finding the n terms of AP? So formula for finding n terms of AP is n by 2, 2a plus n minus 1d. So this is the formula where n is number of terms whose sum you want to compute. A is your first term and d is your common difference. This is one formula through which you can find out basically the sum of n terms of AP. And there is another formula that is of n terms is equal to n by 2 a plus l. Now what is A? A is called first term and L is called last term of the series. Suppose in the question you have been given last term of the series. In that case, you don't need to use this formula. You can directly use the formula sum of n terms is equal to n by 2a plus l. Now suppose the question is find the sum of first 10 terms of the series test. Now this is AP 12, 3, 15, 15, 3, 18. So our first term is 12. Common difference is 3 and number of terms is 10. So we need these three parameters to find out the sum up to 10 terms. So formula is n by 2, 2a plus n minus 1d. So n is 10, 10 by 2. First term is 12 plus 10 minus 1, common difference is 3. So this is 5. 12 2s are 24 plus 9 3s are 27. So this becomes 51. So answer is 255. So sum of first 10 terms of the above series is 255. So in AP, you just need two basic things. One is you have been given the series and you have to find out nth term of the series. Or you have been given n terms, you have to find out first term or common difference. Second thing is you have to find out sum of first n terms of arithmetic progression. So I have already told you the formula, sum of n terms, that is n by 2, 2a plus n minus 1d. And another formula is n by 2a plus l. And I have explained you the scenario as well where the respective formula will apply. So this is your AP arithmetic progression. Now next we have geometric progression. Now geometric progression is basically sequence of terms or succession of terms which are increased or decreased. Now the most important word is by same common ratio. Now, what is the difference between AP and GP? In AP, we have told that items are increased or decreased by same common difference. But in GP, items are increased or decreased by same common ratio. Now, what it means? Suppose these are the terms of GP up to nth item. Now, what it says, what means ratio? The ratio of second term and first term. That is equal to ratio of third term and second term. That is equal to ratio of fourth term upon third term. That is equal to ratio of nth term and n minus 1. That is equal to R, and R is your common ratio. So this is GP, and how we can find out the term? Suppose we'll say the first term is A. Now first term of the series is A and your common ratio is R. So I have already told you the second term is first term, second term is basically, we have told that this is wrong. We have told that second term upon first term, that is equal to R. So first term is basically, you have already explained the first term is A. So if first term is A, then second term upon A is equal to R. So second term is equal to AR. So if first term is A, second term is equal to AR. Similarly, bacha, we have said third term upon second term, that is equal to R. So that means third term is second term into R. Now second term is AR into R. So third term becomes AR squared. So if I want to find out nth term, so the formula is AR n minus 1. This is the formula of finding the nth term of GP, that is AR n minus 1. Suppose we have been given the series this 1, 3, 9, 89, 27, 81. So just check it out, the common ratio, second term upon first term, third term upon second term, all this is equal to 3. So common ratio is 3 and first term is 1. So suppose I have to find out seventh term. So that is AR n minus 1. A is 1, R is 3 and N is 7 minus 1. This is equal to 3 raised power 6. So just check it out. 3 raised power 4 is 81, 3 raised power 5 is 243, 3 raised power 6 is equal to 729. Now let's have a look at another question. A series is given as 7, 14, 28, 56, 112. Identify the type of the series. So in this case, we have to find out the ratio. So 14 upon 7 equals to 2, 28 upon 14 equals to 2, 56 upon 28, that is equal to 2. So when common ratio is same, that means this is called GP. So what is A? A is your first term, so this is your A, and common ratio is your 2. So now another question. For the given series, find the value of A and R and identify the type of the series. So in this case, just have a look. The first item is positive, the second item is negative, another third item is positive. That means common ratio is negative. So how we can find out the common ratio? 1875 divided by minus 375. So this is equal to 5. Similarly, 75, so this is minus 5, sorry. 75 upon minus 375. Sorry, Bacha, I have written in wrong way. This is second term upon first term. So that means minus 375 will be the numerator and 1875 will be denominator. So our ratio is 1 upon 5. Similarly, third term upon second term, and that is minus 1 by 5. Now third term is 75 and second term is minus 375. Again, this is minus 1 by 5. Similarly, fourth term upon third term. So fourth term will be minus 15 and then 75. This is again equal to minus 1 by 5. So common ratio is equal. So that's why it is GP. What is A? A is 1875 and what is R? That is equal to minus 1 by 5. So how to find out nth term of GP? I have already told you A, R, n minus 1, where A is your first term, R is your common ratio, and n is nth term which you have to find out. And n is your nth term whose value you want to find out. So this way you can find out the nth term of a GP. Now suppose you have been given the series 1133 and you have to find out nth term. So first term is A, common ratio is 33 upon 11, that is equal to 3. So nth term means AR n minus 1. A is 11, R is 3 and nth term is 9 minus 1. So 11 into 3 raised power 8. So 3 raised power 8, we have already said 3 raised power 6 is 729 into 9 into 11. So your answer is 729 into 9 into 11. So answer will be 72171. This is how you can find out the nth term of GP. Now next, similar way, if you want to find out sum of n terms of GP. So if you want to find out sum of n terms of GP, then there will be two formulas depending upon the value of R. If R is less than 1, then formula is A 1 minus r power n upon 1 minus r. And if r is greater than 1, then a r power n minus 1 upon r minus 1. This is how we can find out the sum of n terms of GP. And there is one more term if we want to find out sum up to infinite terms of GP, which is all sum of infinite terms is only possible in GP, not in case of AP. So if we want to find out sum of infinite terms of GP, so if r is less than 1, then formula is a upon 1 minus r. And if r is greater than 1, then formula is a upon r minus 1. Let's solve few questions. Find the sum of first n terms of the series this. So now we have to find out the sum. So up to n terms. Now what is first term? 5. What is common ratio? That is 10 upon 5, which is equal to 2. So now we have to find out sum of 9 terms of the series. Formula is that is a r, because r is greater than 1, so our formula is r power n minus 1 upon r minus 1. So a is 5, r is 2, and 2 raised power 9 minus 1 upon 2 minus 1. So 2 raised power 9 is 512 minus 1 upon 1. So this is 5 into 511. So your answer is 2555. So that will be the answer. Now next question says find the sum of first 10 terms of the series. Now in this case a is 48 and r is second term upon first term. Now in this case r is 1 by 2, which is less than 1. So sum up to n terms is a 1 minus r power n upon 1 minus r. So a is 48. 1 minus r is 1 by 2 power 10 upon 1 minus 1 by 2. So this is equal to 48. 1 minus 2 raised by 10 is 1024 upon 1 minus 1 by 2. So answer is 48 into 1023 upon 1024 into 2. So this is 512. So 48. So 48 into 1023 divided by 512. So answer is 95.9. We can write it down in fractions as well, or we can write it down in decimals as well. So this is how we can find out sum of n terms of GP when r is less than 1 and when r is greater than 1. Now another question is, if mth term of an AP is 1 by n. Now says mth term of an AP is 1 by n and nth term is 1 by m and m is not equal to n, then show that the first term is equal to common difference. That means a is equal to d. We have to find out. So what it means mth term of AP, that is a plus m minus 1 d, that is equal to 1 by n. What is nth term? A plus n minus 1 d, that is equal to 1 by n. One important point you must remember, whenever such type of questions are there in which m term is equal to n or m term is equal to any value which is constant but value is not defined, in that case, if the series is AP, then you have to subtract both the series, and if it is GP, then you have to divide both the series. Now by subtracting both the series, subtracting second from first, a will be cancelled. This will be m minus n d, that is equal to 1 upon m minus 1 upon m. So this is equal to m minus n d, that is m minus n upon m n. So your m minus n is cancelled. So common difference is 1 upon m n. In the similar way, by putting the value of d in any of the equation, you can find out the value of a. So a plus m minus 1 into 1 upon mn, that is equal to 1 by n. Taking the value on the right hand side, because we have to find out a, 1 upon n minus m minus 1 upon n. Taking LCM, this is mn. So m minus m plus 1. So this is cancelled. So a again is equal to 1 by m. So we just want to find out whether first term is equal to common difference. Yes, first term and common difference both are same. Let's move to further questions. Now, if I say the next question is given, like in this case, if P, Q term are term of an AP or ABC, show that this is equal to 0. Now, Pth term means A plus, now I am taking capital A as the first term because small a is already given in the question. So, A plus P minus 1D, that is equal to small a plus Q minus 1D, that is equal to small b, and A plus R minus 1D, that is equal to small c. So these are the Pth, Qth, R terms of an AP which is equal to ABC. Now we have to find out Q minus R minus P, P minus Q. So if I subtract second from first, so if I say A plus P minus 1D, that is equal to A plus Q minus 1D, that is equal to P. By subtracting both the equations, what it becomes? P minus QD, that is equal to A minus B. Similarly, by subtracting second and third, A plus Q minus 1D, that is equal to B. A plus R minus 1D, that is equal to C. Subtracting now this again, Q minus RD, that is equal to B minus C. Similarly, R minus PD, that is equal to C minus A. Now we substitute these values into the equation. So what is the value of Q minus R? That is B minus C upon D into A. What is the value of R minus P? C minus A upon D into B. And what is the value of P minus Q? That is A minus B upon D into C. So simply D is same as it is LCM. It is available in all the three factors. So AB minus AC plus BC minus AB plus AC minus BC. So if we solve this equation, all the values will be cancelled with each other. So your answer is 0. Next thing is, if x is equal to this is sum up to infinite terms of GP. That means your common ratio is A upon R upon A. That is equal to 1 upon R and first term is A. In this case, your first term is B and your common ratio is minus 1 by R. Because in this case, the second one is negative and third one is positive. And again, in this case, the first term is C and common ratio is 1 upon R square. Okay, so we have to find out, show that x, y upon z is equal to AB upon C. So x is basically sum of infinite terms of the series. So that becomes A upon 1 minus 1 by R. Fine. So this is equal to A upon R minus 1 upon R. So this is equal to AR, R minus 1. Now what is y? This is B upon 1 minus 1 by R. So this is equal to B upon R plus 1. So that is BR upon 1 plus R. And what is Z? That is C upon 1 minus 1 upon R square. So this is equal to C upon R square minus 1 upon R square. So this is CR square upon R square minus 1. Because sum up to infinite terms is A upon 1 minus R when R is less than 1. And generally in infinite terms, R is generally less than 1. So now we have to take left hand side x, y upon z. Now x is AR, R minus 1. Y is BR, 1 plus R, and Z is CR square upon R square minus 1. Now what it becomes, AB R square upon R square minus 1 into R square minus 1 upon CR square. This is cancelled, R square is cancelled, which is equal to AB upon C, and this is equal to a right hand side. Next one is the rate of monthly salary for a person is increased annually in AP. So this says that the salary increased in AP, arithmetic progression. It is known that he was drawing rupees 400 a month during 11th year of service. Now what it means, 11th year matlab 11th term of the series is 400 and 29th term of the series is 760. You have to find out the starting salary and rate of annual increment, that means common difference. So what it means, 11th term, that means A plus 10B, that is equal to 400. And what is 29th term? A plus 28D, that is equal to 760. Subtracting both the equations, so this becomes minus 18D is equal to minus 360. So D is equal to 20, common difference is 20. And first term is A plus 10 into 20, that is 400. So A is equal to 200. So this way you can find out first term and common difference. Now you have to find out the salary at the time of retirement just on completion of 36 years of service. That means we have to find out T36, which is equal to A plus 35D. A is 200 and common difference is 20. So this becomes 700 plus 200, 900. So this way you can find out the value, that is 900. I hope this is clear to everyone. The way we can compute the different values. Clear? Now next concept is, let's move to the next question. Now this says a man secures an interest-free loan of rupees 14,500 from a friend and agrees to repay it in 10 installments. That means we have to pay the entire loan amount in 10 installments. So sum of 10 installments is 14,500. He pays rupees 1,000 in first installment. So first installment, that means A is equal to 1,000. And then increases each installment by equal amount over the preceding installment. That means common difference is D. What will be his last installment? So we have to find out last installment, and we already know that the number of installments is 10. So we have to find out T10. Fine. So, but to find out T10, first we need to find out the value of D. And D we can find out by using the formula of sum of n terms. So sum of n terms is n by 2, A plus 2A plus n minus 1 D. So sum of n terms is 14,500. Number of terms is 10, 10 by 2. 2A means that is 2 into 1,000. N minus 1 means 9 and common difference is D. So this is 2 5s are 10 and 5 2s are 10, 5 9. This is equal to 2,900. 2,900 minus 2,000, that is equal to 9D. So D is equal to 900 upon 9, which is equal to 100. Now we've found the common difference. Now we can easily find out the 10th term, that is A plus 9D. A is 1,000 and D is 100. So that means our 10th term is 1,900. Now next is find out the sum of first 15 terms of a GP given by this. So this is GP, then A is 1 and common ratio is minus 1 by 2 upon 1, which is equal to minus 1 by 2. So we have to find out sum up to 15 terms. So formula is A 1 minus R per n upon 1 minus R. So A is 1 minus 1 by 2 per 15 upon 1 minus 1 by 2. So this is 1 minus 1 by 2 per 15. 2 per 10 is 1,024. 2 raised per 5 is 32. So if we both 1,024 into 1024 into 32. So that becomes 32768. So this is 1 minus 1 plus, this becomes 1 upon 32768. And in the denominator, it becomes 1 plus 1 by 2. So this becomes 32769 upon 32768 into 2 by 3. So this is divisible by 3. 3 ones are 3, 3 nines are 27, 3 twos are 6, 3 threes are 9. And this is 16384. So that will be the answer. So this is about AP and GP, how we can find out different values. Another question. Mr. X arranges to pay off a debt of rupees 9600 in 48 annual installments, which form an AP. When 40 of these installments are paid, Mr. X becomes insolvent with rupees 2400 still remains unpaid. That means when 40 installments are paid, that means sum of 40 installments, that is equal to 9600 minus 2400. So this will be 7200. Fine. So when 48 installments, so and sum of 8 installments, that is equal to 2400, because 40 installments have already been done. Or you can say sum of 48 installments is 9600 and sum of 40 installments is 7200. So this is 9600, that is equal to 48 upon 2, 2a plus n minus 1, that is 47d. So 224, so that means 2a plus 47d, that is equal to 400. This is your first equation. Second equation, you can find out 7200, that is 40 upon 2, 2a plus 39d. So this becomes 360. So 2a plus 39d is equal to 360. Minus, minus, minus. So that is 8d is equal to 40, d is equal to 5. So common difference is 5. And first term you can find out 2a plus is equal to 360 minus 39 into 5. That is 195. 360 minus 195, that becomes 175 upon 2. So this is 87.5. So our first term is 87.5. Okay, and our common difference is 5. So they say what is the value of second installment? So second installment will be D, because 87.5 is first term. Common difference is 5. So when we add 5, then it becomes 92.5. So this is the way you can find out different questions depending upon what type of question is this. We can find out the arithmetic progression and GP, geometric progression. Now this is the question. Find sum of all natural numbers from 100 to 300 which are divisible by 4. So from 100 to 300. So there is no word between. This is from. So 100 plus 104 plus 108 up to 300. So your first term is 100, your common difference is 4, and you have to find out number of terms. So you can take any example. So we'll say the nth term is 300. So a plus n minus 1 d is equal to 300. N minus 1 d, that is equal to 200. N minus 1 equals to 50. So n is equal to 51. And we have to find out sum of all natural numbers. So sum of 51 terms is 51 by 2, 2a plus n minus 1, that becomes 50. Common difference is 4. So this is 51 upon 2, 2 into 100, that is 200, plus 50 into 4, 200. So that means this becomes 10,200. So this is the answer. Now, if you want to find out, insert arithmetic means between two numbers x and y. So whenever we have to add certain numbers of arithmetic means between two numbers, then it becomes arithmetic progression. So now we want to insert 9 arithmetic mean between 1 by 4 and minus 39 by 4. It means 9 arithmetic mean we have to insert, and there are 2 more items. So 11th term of the series is minus 39 by 4. So this is a plus 10d is equal to minus 39 by 4. First term is 1 by 4. 1 by 4 plus 10d is equal to minus 39 by 4. 10d is equal to minus 40 by 4. That is minus 10. So d is equal to minus 1. So your d is minus 1. Then first arithmetic mean will be 1 by 4 minus 1. So that is minus 3 by 4. So this is how you can find out the different questions of AP and GP. Now we have been given sum of this is up to 25 terms. So A is 3 by root 5. Common differences, you can say 1 by root 5. So you have to find out sum up to 25 terms. That is 25 by 2, 2A plus n minus 1, 24. D is 1 upon root 5. So this is 25 by 2. 2 3s are 6 plus 24, 30 upon root 5. So this is 15. So your answer is sum up to 25 terms. 25 by 2, 2a plus n minus 1 d. N minus 1 is 24. So 2 into 3, 6 root 5, 6 upon 24, 30 upon root 5. Okay, so if we rationalize it, root 5 upon root 5, okay, so answer will be 25 into 15 into root 5 upon 5. So answer will be 75 root 5. That will be the answer. Right? So this is how you can find out the value. So this is your series, arithmetic progression and GP, geometric progression. Now your next topic is time and distance. You know which are time is time required and speed. Distance is whatever the distance you have been traveled. So speed is basically the rate at which you have covered the distance. So there is a relationship between time, speed and distance. What is that relationship? Distance is equal to speed into time. So that means speed is equal to distance upon time. So on the basis of this relationship, whatever the 2 items have been given, we can easily find out the third item. Distance is generally in kilometers. Speed is in kilometers per hour or per minute, and time is in hours or seconds. So depending upon whatever the unit of distance speed is, we will compute the time. So this is basically your first portion of mathematics, in which there are 4 topics: ratio proportion, time value of money, arithmetic progression and geometric progression, and 4th one is time, speed and distance. So please solve the questions of these units, and whatever you have doubt, you can discuss it. You can WhatsApp me your doubt on my WhatsApp number that I have already shared with you in the last class. Now next thing is, let's discuss another topic, that is basically here indices and logarithm. Now next topic is indices. Sometimes in few books you have been written the name of the concept as surds or indices. Now what is this indices or surds? This is how you can simplify the exponential functions. Now what is this exponential functions? Exponential function is the function which is written in the form of a power n. That is called exponential function. First we'll discuss indices and logarithm, then we'll discuss sets function. So indices is simplifying exponential functions. And exponential function is a function which is defined in the form of a power x. This is called exponential function. This is basically exponential function. What it means, multiply a x times. The meaning of this word is a power x, that is multiplying a x times. Now what is this a? A is called base or index. Base. And x is called power or index. Fine. So whatever the function is written in the form of base and power, that is called exponential function. Now if I say find the value of 1.25 to the power of 5, so that means 1.25 power 5. So that means we have to multiply 1.25 5 times. So I have already explained you 1.25 into square. This is square, cube, 4 and 5. So answer is 3.05. So if I say find the value of 2.5 per 5, so multiply 2.5 5 times. So sometimes you have been given root, like suppose I'll say cube root of x. So what it means, the power of x is 1 by 2. Whenever your power is in the form of roots, then root is always considered as inverse part. Now if I say fifth root of y, that is equal to y power 1 by 5. So there are certain basic rules of indices. The first rule is, that is product rule. Now what product rule says, suppose you have two exponential functions, one is a power x and another is b power y. They are multiplying with each other. Okay? And the exponential function in such a way that neither x is equal to y, means neither their base are same or nor their powers are same. Neither base are same nor powers. In that case, you have to first calculate a power x, then calculate b power y and multiply. Like suppose if I say 2 raised power 3 and 3 raised power 2. Nothing has been same, base is different, powers are different. So what we have to do, 2 raised power 3, 8, 3 raised power 2, 9. So product is 72. Another thing is we have two exponential functions which are multiplying each other such that their base are same. So if their base are same, that means this becomes a power x into a power y. So if two exponential functions are multiplying with each other whose base are same, then their powers will be added, that is equal to a power x plus y. 2 raised power 3 into 2 raised power 2. So this becomes 8, this becomes 4, this is 32, which is equal to 2 raised power 5. So we can simply solve it by adding the powers. So this is called your product rule. Third is, suppose there are two exponential functions which are multiplying each other such that their powers are same. That means a power x, b power x. So we can multiply the base and keep the power as x. So this is another example of product rule. Next is division rule. Now division rule, what it says, two exponential functions are divided. So this is a power x upon b power y. These are two exponential functions which we are dividing with each other such that neither base are equal nor power are equal. So in this case, you don't have any other option to simplify it. Just you have to solve a power x, then b power y, and then divide. Similarly, 3 raised power 2 upon 2 raised power 3. So that means 3 raised power 2, 9, and 2 raised power 8, 3, 8. So this is the answer. Another thing is we have two exponential functions which are dividing each other such that their base are same. That means this is equal to a power x upon a power y. So when two exponential functions are dividing whose base are same, then their powers will be subtracted. This is equal to a power x minus y. So if I say 3 raised power 5 upon 3 raised power 2. So this is 3 raised power 5, that is 243, 3 raised power 2, that is 9. So your answer is 9 2s are 18, 9 7s are 10, which is equal to 3 raised power 3. So we simply subtract the powers and value is equal to 3 raised power 3. Another rule says we have two exponential functions in such a way that their powers are same. So that means a power x upon b power x. So we can keep it in this way, a upon b power x. This is called your division rule. Now next thing is power rule. I have already told you, if you have a square root, cube root, nth root of a, that is equal to a power 1 by n. And if we have an exponential function which has some power, e power m power n, so that means powers are multiplied each other. Similarly, if an exponential function has power 1, that is equal to 1. And if exponential function has negative power, that means the inverse of that exponential function makes its power negative. So a power minus x, that is equal to 1 upon a power x. Another very important rule, if two exponential functions are equal, then if there is some relationship between them, if their base are same, then that means their powers are also same. And if their powers are same, that means their base are also same. These are the basic rules of indices. Now on these rules, we have to simplify the questions. Now the first question is, a power x is equal to a power upon k power y, that is equal to k power m. Then n is not equal to 1. So we can write it in this way, a power x is equal to a power y upon k power y is equal to k power m. So what it becomes? This becomes a power x upon a power y, that is k power m into k power y. Fine. Or we can write it in this way, a power x minus y is equal to k power m plus y. So, but it won't help us because our base are different. We have to try to make the same base. Now this is a power x is equal to a upon k power y is equal to k power m. So that means a power y is equal to a power y is equal to a power x k power y, and k power y is equal to, this becomes a power x is equal to k power m. So k power m into k power y. So this becomes y is equal to m plus y. No, just a second. We have been given a power x is equal to a upon k power y is equal to k power m. So we'll say a power x k power y is equal to a power y is equal to k power m. Then k power y is equal to a power y upon a power x. So k power y is equal to a power y minus x. So k is equal to a power y minus x power 1 by y. So that means k is equal to a power y minus x upon y. Now putting this value into k power m. So if I put the value of k in k power m, this is equal to a power y minus x upon y power m. So this becomes k is equal to, k power m is equal to, or we can say multiplying m on both sides. Multiplying m on both sides. In this equation, taking m power on both sides. Taking m power on both sides. So this becomes k power m is equal to a power y minus. So k power m is equal to a power y minus x into m upon y. But k power m is equal to, we have been given, that is equal to a power x. K power m is equal to a power x. So substituting the value of a power m as a power x. So we'll say a power x is equal to a power y minus x upon y into m. So I have already told you, if two exponential functions are equal such that their base are same, that means their power are also same. So this becomes x upon m, that is equal to 1 minus x upon y. So that means we have to find out 1 upon m, that is equal to 1 upon x minus 1 upon y, because we took x, we divide x on the right hand side, this becomes 1 upon x, and in this case x and x will be cancelled. So 1 upon m is equal to 1 upon x minus 1 upon y. So this is the way you can find out the question. Now next question is x upon y is equal to z upon y. Then you have to find out the value of this. So that means whenever you have been given equal to, so x is equal to yk and z is equal to wk. Now substituting the value into this equation, x bar m, x is equal to yk. So this becomes yk bar m plus y bar m plus wk bar m plus wm. Now in x yk bar minus m plus y bar minus m plus wk bar minus m plus w bar minus m. So if we find out the factors, this becomes y bar m k bar m plus y bar m plus w bar m k bar m plus w bar m. Similarly, y bar minus m k bar minus m plus y bar minus m, w bar minus m k bar minus m plus w bar minus m. Y bar m common, this is k bar m plus 1 plus w bar m common, k bar m plus 1. Similarly, in this case, y bar minus m common, k bar minus m plus 1. And in this case, w bar minus m common, k bar minus m plus 1. So this becomes k bar m plus 1, y bar m plus w bar m upon k bar minus m plus 1 and y bar minus m plus w bar minus m. So we can write it down k bar minus m as 1 upon this. So after this, if we just look it out, this is 1 upon km plus 1. So this is k bar m plus 1 and y bar m plus w bar m. And k bar minus m is 1 upon k bar m plus 1, 1 upon y bar m plus 1 upon w bar m. So this is equal to k bar m plus 1, y bar m plus w bar m. This becomes 1 plus k bar m upon k bar m into y bar m plus w bar m upon y bar m w bar m. This is cancelled. So your answer is k bar m, y bar m, w bar m. So that is the answer. So in indices, you have to just simplify. But we have to prove it equal to x, y, z, w. Now simply substitute the value of k, y and m. So we have x is equal to, so we took right hand side, x is equal to yk, y is as it is, z is equal to wk, w as it is. So this becomes y square, k square, w square. So this will be cancelled. This is equal to y bar m, k bar m, w bar m. Now next question is 6 bar 2x plus 4 is equal to this. Whenever you have such kind of questions, you have to try to keep the base with the smallest prime number, like 3, 6. We can write it down 2 into 3 bar 2x plus 4. That is equal to 3 bar 3x into 2 bar x plus 8. So this is 2 bar 2x plus 4 into 3 bar 2x plus 4. And we can put the right hand side in the denominator, 3 bar 3x into 2 bar x plus 8 equals to 1. So 2 power 2x plus 4 minus x minus 8. 3 power 2x plus 4 minus 3x, that is equal to 1. So this becomes 2 raised by 2 x minus 4. So this is into 3 raised power minus x plus 4 equals to 1. So we can write it down in this way as well. 2 power x minus 4 upon 3 power x minus 4. So if we want to take any exponential function in the denominator, then we have to keep the sign negative. So x minus 4, that is equal to 1. So 2 power x minus 4, that is equal to 3 power x minus 4. Their base are different, but their powers are same. So when their powers are same, that means there is some relationship. 2 power x minus 4, 3 power x minus 4. So that becomes 2 by 3 power x minus 4. 2 upon 3 is equal to, and that is equal to 2 by 3 power 0. Now we have done in this way. The power is same, so we write it down 2 upon 3 power x minus 4, that is equal to 1. So we can write out this thing, 2 upon 3 power x minus 4, that is equal to 2 upon 3 power 0. Because any exponential function whose power is 0, that is equal to 1. Base are same, then powers are same. So x is equal to 4. Now next question. Simplify this question. Simply all the bases are x. Those who are multiplying, their powers will be added, and those who are dividing, their powers will be subtracted. So this is x power m plus 2n plus 3m minus 8n minus 5m plus 6m. So this is m plus 3m 4m, m plus 3m 4m minus 5m. So that is equal to x power minus m. 2n plus 6n minus 8n, that is 0. So x power minus m, that is equal to 1 upon x power m. So this is the answer. Similarly, next question, we have been given 6 power x, 2 upon 3 power y. So this is in this way written. So first simplified, 6 power x means 2 into 3 power x upon 2 upon 3 power y minus 3 into 2 power x plus y minus 8 into 3 power x minus y plus 24 equals to 0. So this becomes 2 raised power x plus y into 3 raised power x minus y. Or simply do one thing, try to find out some value. So we'll say 2 raised power x, 3 raised power x into 2 raised power y, 3 raised power y minus 3 into 2 raised power x, 2 raised power y minus 8, 3 raised power x, 3 raised power minus y plus 24 equals to 0. So if we solve it, so we have to take the values like as we done it in the previous question. So this is 2 raised power x plus y into 3 raised power x minus y minus 3 into 2 raised power x plus y minus 8 raised power 3x minus y plus 24 equals to 0. So we can do one thing, we can assume 2 raised power x as x and x plus y, x minus y. So if I say 2 raised per x plus y, 3 raised per x minus y, minus 3 into 2 raised per x plus y, that is equal to 8 into 3 raised per x minus y plus 24. Now next thing is 2 raised per x plus y, if I say common. So this becomes 3 raised per x minus y minus 3 raised per 1. And in this case, if I make common 8, so this becomes 3 raised per x minus y minus 3. Because this 24, when we take it on right hand side, this becomes negative. So 3 per x minus y, 3 per x minus y, 3 is cancelled. 2 raised per x plus y is equal to 8. So 2 raised per x plus y is equal to 2 raised per 3. So x plus y is equal to 3. We have been given xy is equal to 2. So that means either x is 1, y is 2 or y is 1, x is 2. Only then we have xy equals to 2. So this is your answer. Obtain the simplest value. So in this case, first you have to open the innermost brackets. That is 1 minus x cube power minus 1. So this becomes 1 minus 1 upon 1 minus x cube. Solve it. But it becomes 1 minus x cube. 1 minus x cube minus 1. So this is cancelled. So this becomes 1 minus x cube upon minus x cube, or if I take negative sign common from both the sides, this becomes x cube minus 1 upon x cube. So I have solved this one. Now next thing is 1 minus, then we have square brackets and 1 by 3. So this is again LCM x cube minus x cube plus 1. This is cancelled. So again this is minus 1 by 3. So we'll again compute the inverse. So this is x cube into 1 by 3. So answer is x. So our answer is x. Okay. Now next question is, if x is equal to 3 raised per 1 by 3 plus 3 raised per minus 1 by 3, prove that this is equal to 10. So if x is this, then means we have to find out x cube, taking cube on both sides. X cube is equal to 3 power 1 by 3 plus 3 power minus 1 by 3 cube. So that is x cube, a ka cube, a's cube plus b cube plus 3ab, and this is a plus b. So we'll say x cube is equal to 3 plus 3 power minus 1 plus, this will be cancelled 3, and this is equivalent to x. That means x cube minus 3x, that is equal to 3 plus 1 by 3. So x cube minus 3x is equal to 10 by 3. So multiplying 3 on left hand side, 3x cube minus 9x equals to 10, hence proved. Now next thing is, if 2.381 per x is equal to 0.381 per y equals to 10z. Whenever you have been given the question in this form, just equate it equal to k. So that means 2.381, that is equal to k per 1 by x. 0.2381, that is equal to k per 1 by y. And 10 is equal to k per 1 by z. Now this is the thing. Now next thing is, we have been given, just have a look, 2.381 upon 0.2381, that is equal to 10, because this is 0.2381 upon 1000, 0.381, that is equal to 10. Now what is this 2.381? This is k power 1 by x. What is 0.2381? That is k power 1 by y. That is equal to k power 1 by z. So k power 1 by x minus 1 by y, that is equal to k power 1 by z. So if base are same, then powers are same. 1 upon x minus 1 upon y equals to 1 upon z, or we can say 1 upon x is equal to 1 upon y plus 1 upon z. So this is basically indices. Now next question is, we have been given x is equal to this and y is equal to this. First we have to compute x square and y square. So x square is 3 raised power 1 by 4 plus 3 raised power minus 1 by 4 whole square. So this is equal to a square plus b square plus 2ab. So this is cancelled. This becomes 3 raised power 1 by 2 plus 3 raised power minus 1 by 2 plus 2. Similarly, 3 raised power 1 by 4 minus 3 raised power minus 1 by 4 square, that is 3 raised power 1 by 4 ka square plus 3 raised power minus 1 by 4 whole square minus 2ab. Again, this is cancelled. This is 3 raised power 1 by 2 plus 3 raised power minus 1 by 2 minus 2. Now we have to add both the numbers x square plus y square. So this becomes 3 raised power 1 by 2 plus 3 raised power minus 1 by 2 plus 2 plus 3 raised power 1 by 2 plus 3 raised power minus 1 by 2 minus 2. That is, this one is cancelled, square. So this is 2 into 3 raised power 1 by 2 plus 2 into 3 raised power minus 1 by 2 whole square. Left hand side we are taking. So 2 ka square common, we have taken 2 raised 2 square common. So 2 2s are 4, 3s are 12. Then a square plus b square plus 2ab. This will be cancelled. So 12, 3 plus 1 by 3 plus 2. So this is 12 into 3 3s are 9 plus 10 plus 6, 16 upon 3. So your answer is 64. So this is the way you can solve different types of questions of indices. Like these are the simplest question, like 1 upon 81. So 1 upon 81 is 1 upon 3 power 4. Power minus 3 by 4. So we can write it down 1 power 4 upon 3 power 4 into minus 3 by 4. So this is 1 upon 3 power 4 into minus 3 by 4. So this is 1 upon 3 power minus 3. So your answer is 3 raised power 3, that is 27. Now 243 is 3 raised power 5 into minus 1 by 5. So answer is 3 raised power minus 1 or 1 by 3. So in these questions, we have to, whenever there is an addition or subtraction in between two exponential functions, then we'll try to find out something common. So we can write it in this way: 2 into 3 raised power n into 3 raised power 1 plus 7 into 3 raised power n into 3 raised power minus 1 upon 3 raised power n into 3 raised power 2 minus 2. This is 1 upon 3, that means into 3 raised power minus 1 into 3 raised power n. So taking 3 raised power n common from numerator as well as denominator, 3 2s are 6 plus 7 by 3 upon 3 raised power n, 3 raised power 2 9 minus 2 into 3 power minus 1. So that is 2 by 3. Fine. So this is cancelled. This is 3 6 are 18 plus 7, 25 by 3. 3 9s are 27 minus 2, 25 by 3. So both will be cancelled. Answer is 1. So this is which are different sort of questions of indices. Now let's move to the next concept, and that next concept is logarithm. But a logarithm is inverse of exponential function. Logarithmic is inverse of exponential function. Means if we have such kind of exponential function which cannot be simplified, then to solve it, we took the help of log. Now suppose y is equal to a power x. Okay, so to solve this kind of questions, we took the help of log. Logarithm is basically having two things. One is called base and another is called value. This is base and this is value. Whose log you have to find out. So there are two bases of logarithm. One is called natural base, which is represented by e, and another is decimal base. In case of decimal number system, we took the base 10, and when the value is not defined, we took value ABC, then we took the base, natural base, that is E. So log has some rules, laws. First, understand the laws. The first thing is, if you are computing the log of product of two numbers, that is equal to sum of individual log of items. So this is log of product of items, that is equal to sum of individual log of items. That means if you are computing log of 5 into 7, that means that is equal to log 5 plus log 7. Similarly, if you are computing log of division of two items, that is equal to difference of individual log of items. That means if the question is log of 4 by 3, that is equal to log of 4 minus log of 3. Third rule is, if we are computing log of any of the exponential function, then power of exponential function is basically multiplied by the log value, that is equal to x log a. Okay, this is the third property. And whatever the power is, that is multiplied to the log. And if we are computing log of any value whose base is 1, that is always equal to 0. And the thing is this, the base of log should always be greater than 1. Would always be greater than 1, because base 1, in that case log of every item is 0, and if base is 0, then log of any item to the base 0 is minus infinity. Okay, for any logarithm their number is 1 and base is positive number, so log of 1 to any base, that is always equal to 0. The base of logarithm for a number would be equal to reciprocal of log with the number replaced by the base. The thing is this, if we are computing log in such a way that base and value are same, that is equal to 1. And suppose you have to compute log of x to the base y, so we can change the base by simply log x upon log y. Now whatever the base you want to put, you can put now. This is called base changing formula. So these are the different concepts of log. Now the question is, express in simplified form. But whenever you have been given function, exponential function, how the log will be applied? Taking log on both sides. When we took log on both sides, this becomes log y is equal to log of a power x. Now what it means log y, I told you that whenever there is a power in log function, this is multiplied by the log value x log a. Now I did log y upon log a, that is equal to x. Now it is written in this form, log y to the base a equals to x. So if you want to compute log 49 to the base 2, that means this becomes log 2 7 whole square. So this becomes 2 log 7 to the base 2. Similarly, express it in simplified form. This is called log 97 to the base 2 minus log 7 to the base 2, because log of division of two items is equal to individual difference of log of items. Similarly, log of product of two items, that is equal to individual sum of log of items. Expresses difference of two logarithms, log 50 upon 2 with base 2. So that means your value is log 50 upon 2 to the base 2. So this is in this way log 50 minus log 2 to the base 2. So log 2 to the base 2 is equal to 1. Whenever the base and power are same, the value is 1. So this is the answer, log 50 to the base 2 minus 1. Now, if you want to find out the value of such kind of questions like log 64 to the base 2, you have two ways. You can convert the log value into exponential function, or you can simplify it using log value as well. Now, suppose log 64 to the base 2 is equal to x. So 2 raised per x is equal to this. So 2 raised per x is equal to 64. 2 raised per x is equal to 2 raised per 6. X is equal to 6. This is one way of solving the question. Another way out is take base value into numerator and base into denominator. Now, what is log 64? This is 2 power 6 upon log 2. We can write it in this way, 6 log 2 upon log 2. Log 2 will be cancelled. Your answer is 6. Now next is express with base value as 3. So base value as 3, log 3 to the base 2. So that becomes log 3 upon log 2. Okay, so if we want to write it down in the form of base value as 3, so we have to take inverse. So that means log of 1 upon log. If we basically change the values, then it becomes inverse. So that is 1 upon log 2 to the base 3. Because the thing is this, like if I convert it into exponential function, 3 base 2 is equal to x. So 2 power x is equal to 3. So that means 3 power 1 by x is equal to 2. So this way you can find out the value. Now next thing is find the value of 3 log 3 to the base 9. So whenever we have to compute, but it becomes 3 log 3, 9, we can write it this way, 3 raised by 2. So this becomes 2 log 3 to the base 3. So whenever log 3 to the base 3, it becomes 1. So answer is 3 raised by 2, that is equal to 9. Find the logarithm of 2025 to the base 3 root 5. Convert this log value into exponential function. This is base, this is power, this is value. So that means 3 root 5 per x is equal to 2025. Now find out the roots of 2025. So roots of 2025 is 5 4s are 20, 0 5, 5 8s are 41. So now we have 3 raised by 4. That means 3 raised by 4, 5 raised by 2. So we can write it this way, 3 raised root 5 per x is equal to 3 per 4 root 5 per 4. So this becomes 3 root 5 per x is equal to 3 root 5 per 4. When base are same, then powers are also same. Now next question is, if log x to the base 2 plus log x to the base 4 is equal to this, find x. Now we don't know what is the value of this x. So we have to find out the value. So what it becomes? Log x upon log 2 plus log x upon log 4. I basically used base changing formula log x upon log 16, that is equal to 21 by 4. Now log x I took common. This becomes 1 upon log 2 plus 1 upon log 2 ka square, 1 upon log 2 raised by 4, that is equal to 21 by 4. Again, what we have done, log x power multiply 2 log 2 plus 1 upon 4 log 2. So what we have done, we have took log 2, 1 upon log 2 common. So this becomes 1 plus 1 by 2 plus 1 by 4, that is equal to 21 by 4. So if I take log x to the base 2, 4 plus 2 plus 1, that is 21 by 4. So 4 cancels, 7 3s are 21. That means log x to the base 2 equals to 3. So x is equal to 2 raised by 3. So your answer is 8. So this is basically the question. Now next question is, if x is equal to log a to the base 2a, y is equal to log 2a to the base 3a, then we have log 3a to the base 4a. How we can find out the value? So we have x is equal to log a upon log 2a. Y is equal to log 2a upon log 3a. And z is equal to log 3a upon log 4a. Now what is this x, y, z plus 1? First we compute x, y, z. X, y, z means log a upon 2a into log 2a upon 3a. Log 3a upon 4a. This is cancelled, this is cancelled. So x, y, z is equal to log a upon log 4a. Now plus 1, adding 1 on both sides, plus 1. So this becomes log a plus log 4a upon log 4a. So this becomes log a plus log 4a. This becomes a into 4a upon log 4a. This becomes log of 4a square upon 4a. Now 4a square means we will say 2a whole square. So this becomes log 2a whole square to the base 4a. That becomes 2 log 2a 4a. Okay, so we have to compute equals to this thing. So 2a 4a, that is equal to yz, because if we multiply y with z, this becomes log of 2a upon 4a. So that is equal to 2 log 2a log 4a square 2a 4a square to the base 4a. So this is our value. They took right hand side 2yz. So this becomes 2 into log of, you can say 2a upon log 3a into log 3a upon log 4a. So this is equal to 2 log 2a upon 4a, which is equal to right hand side. Left hand side is equal to right hand side. Prove that log of AB upon the base A plus log AB to the base B equals to 1. We can write it in this way, 1 upon log AB upon log A by applying base changing formula, plus 1 upon log AB upon log B. Taking inverse, this becomes log A upon log AB plus log B upon log AB. Log AB is LCM, which is equal to log A plus log B. So this is equal to log AB upon log AB, which is equal to 1. So this is your indices and logarithm. Now let's discuss the next concept, and that concept is sets and Venn diagram. We have done indices and logarithm. Now next concept is sets and Venn diagram. What do you mean by sets? How we can solve the question of sets using Venn diagram. So let's start with sets and Venn diagram. So this is the concept, set theory and Venn diagram. What is set? Set is well-defined and distinct collection of objects. Well-defined and distinct collection of objects. Now what it means well-defined? Well-defined means it is already known in advance which one is the part of the collection, which element is part of the collection, and which element is not the part of the collection. And distinct means there is not even a single item which is duplicate. So this is called sets, well-defined and distinct collection of objects. Set is always represented by capital letters, and the elements of sets are represented by small alphabets. Whatever the elements which belongs to the set, they are called elements or member of the set. So next thing is, whenever we have to represent a set, we represent it in curly braces by separating commas. So if I say A is vowel of English alphabet, then we write down the elements A, E, I, O, U in curly braces separating by comma. Now, there are two ways of representation of sets. One is called set builder form, another is roster form or tabular form. There are two ways through which we can define the elements of set. In roster method, we define the set by listing all the elements of the set. When we define the set by listing all elements of set, that is called roster form. So in roster form, we use only in the scenario when number of elements are finite. Then we use roster method. And when we represent the set by listing the property, satisfied by all the elements of the set, that is called set builder form. So when we list out the property, that is called set builder form, and when we list out the elements, that is called roster form. So in which scenario we use it? When the number of elements are finite, then we use roster form. And when number of elements are infinite, it is not easy to write down all the elements, then we generally use set builder form. Like suppose set of odd numbers between 11 to 30, this is finite, so we just write down the numbers. This is called roster form. But if we say set of all odd numbers, okay, so set of all odd numbers, that is infinite, in that case we use property. Now we have various different types of sets. Set of sets. We just explained the collection of elements, well defined and distinct. But when the elements are sets themselves, then we say this is called set of sets. Now set comprises not the individual elements, but the sets themselves. Then we say this is called set of sets. Okay, so T is A, B, C, D, which are again sets. So that means T is set of sets. Singleton set, when a set represents only one element, then this is called singleton set. So L has only just one element, that is 33. That means that is called singleton set. Null set, if a set do not have any element, that means that is empty set, void set, null set. That means we'll say A is equal to 5 or A is equal to empty braces. Then this is called null set. Bacha, this one is not null set because 0 is an element of the set. So this is not null set. Empty braces is the null set. Finite set, a set whose number of elements are finite and countable, that is called finite set. Like we can say set of vowels, set of natural numbers between 1 to 10. This is called finite set. Set of elements which are infinite, difficult to count at a particular point of time. Like we can say set of natural numbers, set of real numbers, set of integers. They are called infinite sets. Equal sets. Two sets are said to be equal. Two sets are said to be equal if they have same elements. That means all the elements of A is contained in B. All elements of A contained in B. Similarly, all elements of B contained in A. That means A is a subset of B, B is a subset of A, then A and B are called equal sets. So we say A is equal to 1, 2, 3, B is equal to 1, 2, 3. So all the elements of A are in B, all the elements of B are in A, then we say that they are called equal sets. Now next property is subsets. What is subset? If all the elements of the set are contained in another set, then we'll say set is subset of that set. Now if I say A is equal to 1, 2, 3, 4. B is equal to 2, 3, 4. Now all the elements of set B are contained in A, then we'll say B is a subset of A. And A is superset of A. But when we talk about, now there's an important point, every set is a subset of itself. Empty set is a subset of every set. Phi is a subset of every set. And every set has at least two subsets. One is empty set and another is set itself. Proper subset. Now, in case of proper subset, there is two conditions. The first one is all the elements of set A is contained in B. First condition is all elements of set A is contained in B. And second condition, there should be at least one element in B. There should be at least one element in B which is not in A. That means A is equal to 1, 2, 3, 4. And B is equal to 1, 2, 3, 4, 5, 7. So now all the elements of set A is contained in B and there should be at least one element in B which is not in A. Then we say A is a proper subset of B. So there is two conditions. All the elements of set A belongs to B and there must be at least one element in B which is not in A. Then we say this is called proper subset. So A is a proper subset of B, but B is not a subset of A because there are certain elements of B which are not in A. Now equivalent sets. Equivalent sets are those sets whose order or degree is same. Order is number of elements. Two sets are said to be equivalent if number of sets in both number of elements in both the sets are same. It is not necessary that elements are same. Number should be same. So if suppose I'll say A is equal to 1, 2, 3, 4. B is equal to A, B, C, D. Now both the sets have different elements but their order is same. So they are called equivalent sets. The same number of elements. Universal set. Universal set is largest non-empty set. ठीक है, largest non-empty set out of which other sets are derived, which is all sets are subsets of that set, that is called universal set. So universal set is called space. Yeah, all the elements are called points. Okay, so we say real numbers are universal set because integers, natural numbers, all are defined from real numbers. So we can say real numbers are universal set. Okay, power set of all possible subsets of a set. The set which comprises of all the possible subsets of a set is called power set. Now suppose we can say A is 1, 2, 3, 4. So what are the possible subsets are possible? 1, 2, 3, 4, 1, 2, 1, 3, 1, 4. Then we have 1, 2, 3, 2, 3, 2, 4, 3, 4. ठीक है, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. Then 1, 2, 3, 2, 3, 4 and 1, 3, 4. And last one is 1, 2, 3, 4. And 5 is a subset of every set. So set of all possible subsets of a set, that is called power set. And number of elements in a power set, that is called 2 raised per n, where n is number of elements. So if there are 4 elements, then number of proper subsets that is equal, number of subsets that is equal to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And one which is missing, 1, 2, 3, 4, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, 1, 2, 3, 2, 3, 4, 1, 3, 4, 1, 2, 3, 4 and 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. एक कोई छूट गया, one is left out. So just check it out. 1, 2, 3, 4. 1, 2, 1, 3, 1, 4. 2, 3, 2, 4 and 3, 4. Fine. So 1, 2, 3, 1, 3, 4. 2, 3, 4. So this is possible. Another is 1, 2, 3, 4. And 5 is a subset of every set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1 has been left out. 1, 2, 3, 4, 1, 2, 3, 4. These are the single one. Then 1, 2, 1, 3, 1, 4, 2, 3, 2, 4 and 3, 4. So these are the possible. Then with 3 elements, 1, 2, 3, 1, 2, 4, 1, 2, 3, 1, 2, 4, 1, 3, 4, 2, 3, 4. Okay, 1, 2, 3. I forgot 1, 2, 4. That's why 1, 2, 4, 1, 3, 4, 2, 3, 4, and 1, 2, 3, 4. And last one is 5. So check it out. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 2 raised by n, that is equal to 2 raised by 4, 16. And if somebody asks number of proper subsets, number of proper subsets. So number of proper subsets, that is equal to 2 raised by 4 minus 1, that is equal to 15. So because in case of proper subset, this will be not a part of the set 1, 2, 3, 4. Because in case of proper subset, there should be at least one element in Y which is not in X. Product is called Cartesian product. Now suppose we have two sets. A is equal to 1, 2, 3. B is equal to 2, 4. and we want Cartesian product of two sets. So Cartesian product is well-defined ordered pair of set AB in such a way that A belongs to set A and B belongs to set B. So Cartesian product comprises of 1, 2, 1, 4, 2, 3, 2, 2, 2, 4, 3, 2, 3, 4. So in case of Cartesian product, whatever the pairs, ordered pairs are there, the first element belongs to set A and second element belongs to set B. This is called Cartesian product of two sets. Cardinality or order of set, that is called number of distinct elements in a set, that is called cardinality or order of set. Now if there are 3 elements, cardinality is 3. If there are 2 elements, cardinality is 2. If there is 1 element, cardinality is 1. So important points is every set is a subset of itself. Null set is a subset of every set. Whenever there are 3 sets Q, W, R, then Q is a subset of W, W is a subset of R, and Q is a subset of R. Okay. Now, what are the basic operations which are possible on sets? We can find out union. Now, suppose A is equal to 1, 2, 3, 4. B is equal to 3, 4, 7, 9. So if we are computing union A union B, that means write down all the elements of both the set, but repetition should be written only once. This is called union. And intersection means we have to find out the common elements. So intersection of A and B is 3 and 4 because 2 elements are common in both the sets. Disjoint means when they do not have anything in common, like A is equal to 1, 2, 3, B is equal to 5, 7, 9. So if I compute intersection is equal to 5. That means null set. So such type of sets whose intersection is 5, they are called disjoint sets. Now difference is A minus B. What is A minus B? Subtracting the common elements from A. This is called A minus B. That means A minus A intersection B. That is called A minus B. So if A is 1, 2, 3, 4, 5 and B is 1, 5. So A minus B is just removing the common elements. So this becomes 2, 3, 4. This is called A minus B. Complement is opposite. Now if a universal set comprises of A, then not A. This is called complement of set A. So if universal set has numbers 1, 2, 3, 4, 7, 9 and A has number 2, 3, 7. Then A complement is basically U minus A. That means eliminate the common elements. So that is 1, 9, 2, 3, 1, 9 and 4. This is called A complement. Now next is laws of algebra of set. The first law is idempotent. What it means, A union A, when we perform operation on set, same set. That means A union A, that is called A intersection A, that is called A. This is called idempotent laws. When we perform operations on the same set, then this is called idempotent law. Commutative, A union intersection B is equal to B intersection A. If we want to find out union or intersection in two sets, then whatever the order we follow, the answer will be same. A union B is equal to B union A. Associative always uses 3 sets. A union B union C, that is equal to A union B union C. Similarly, A intersection B intersection C, that is equal to A intersection B intersection C. The answer will be same. In case of distributive, we have different operations. We have union as well as intersection. A union B intersection C, that is equal to A union B intersection A union C. Similarly, A intersection B union C, that is equal to A intersection B union A intersection C. This is called distributive law. De Morgan's law says that if we are computing A union B complement, that means A complement intersection B complement. So whenever we have to complement, we convert union into intersection and set into its complement. Similarly, A intersection B complement, that is equal to A complement union B complement. Identity law, you can say A union universal set, that is universal set. A intersection universal set, that is equal to A union phi, that is equal to A intersection phi, that is equal to phi. Complement law, A union A complement, that is equal to universal set. Phi complement is equal to universal set. Universal complement is equal to phi. A union A complement, that is universal. A intersection A complement, that is phi. Complement of a complement, that is equal to A. Now the most important thing is how to solve the questions related to Venn diagram. Now suppose we have been given questions. These are the formulas. Whenever we have to find out the union N A union B, that is equal to N of A. If the elements are disjoint, then A union B is equal to N of A plus N of B. But if they are not disjoint, that means there is something common. In that case, A union B, that is equal to N of A plus N of B minus N of A intersection B. Similarly, if we want to find out three elements, A union B union C, if they are disjoint, then simply N of A plus N of B plus N of C. But if they are not disjoint, then A union B union C, that is equal to N of A plus N of B plus N of C minus N of A intersection B minus B intersection C minus A intersection C plus N of A intersection B intersection C. Now suppose the question is, we'll take say, now set A, B. A union B means write down all the numbers of A and B. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A intersection C. A and C. Elements common are 2, 4. B intersection D. B and D. The elements are 7 and 9. A intersection D. Elements are 10. 6, 8, 10. Union of Q and W, that is 1, 2, 3, 4, 5, 7. Okay, intersection. So intersection is -2, -1 because the common elements are -2 and -1. A complement. If A is this, then universal minus A, that is called A complement. So we have -5, -4, -3, -2, no, -1, 0, 1, 2, 3, 4, 5. That is called A complement. Find the difference of Y minus T. So Y minus T means the common elements of T will be removed from Y. So that is Y cancel, U, P, O, no, W, R cancel. So this is W, U, W is also there, U, P, O. Okay, universal set minus A complement. Universal set minus A complement, that is equal to A. Now next thing is how to solve the questions of Venn diagram. Let's do the questions of Venn diagram. In a class of 100 students, 45 students read physics. It means number of physics students is 45 and 100 students is universal set. 52 students read chemistry and 15 students read both the subjects P and C. find the number of students who study neither physics nor chemistry. इसका मतलब we have to find out P complement and C complement. That means this is N of P union C complement. And how to find out P union C complement? That is universal set minus P union C. So universal set is 100 and P union C is N of P plus N of C minus N of P and C. So that is 100 minus 45 students read physics, 52 chemistry, 15 both. So this is 97 minus 15. That is 82. So 100 minus 82, answer is 18. Next is, in a survey of 1000 families, it is used that 454 use electricity, 502 use gas, 448 use kerosene, 158 use gas and electricity, 160 use gas and kerosene, 134 use electricity and kerosene. If all of them use at least one of the three, find how many use all the three. That means we have to find out N, E, and G and K. So how we can solve it out? First we have to find out union E, union G, union K, that is equal to 100. So 100 is equal to electricity users 454 plus 502 gas, 448 kerosene minus 158 minus 160 minus 134 plus N of electricity and gas and kerosene. So this is equal to, subtract this value from 1000. So 454 plus 502, that is 956 plus 448. 1404 minus 158, 8412, 5639, 615, 234. 452 subtract किया. 952, 1000 minus 952, that is 48. So there are 48 persons who use all the three. So that is all about your sets and Venn diagram. So that is all about the classes. If you have any doubts, there are no doubts at all. So in the next class, we'll discuss the statistics portion. So mathematics, we have done a lot. So this will help you in clearing your exam. So that's all for today, bacha. Thank you. And if you have any doubt, please ask your doubts. Any doubt, bacha? Thank you. Thank you very much. My WhatsApp number is 98140-98480. So that's my WhatsApp number, Vasha. You can, whatever your doubts are, you can ask your doubts on this WhatsApp number. Anything else? Want to ask anything? Anything else, Vacha? So that's all, sir. Thank you.
Thank you, madam. Thank you,
Thank you,
students.
sir. Thank you. Thank you,
Bye,
sir.
ma'am. Bye,
Bye,
students.
sir.
Bye, ma'am.
Bye, everyone. Thank you.